Okay, for this lesson, we're going to take a look at some special triangles, the exact values, and most importantly, how they fit into what's called the unit circle, which we use to calculate exact values and exact angles based on what those ratios are. Now, the key reference angles that we use are 0 degrees, 30 degrees, 45, 60, and 90. And we build out our entire unit circle based on these specific angles. So to start with, if we're investigating 45 degrees would mean that my opposite and my adjacent are equivalent, because this would be 45 degrees, this would be 45 degrees, and this obviously is going to be 90 degrees. If the two angles are the same, then it's an isosceles triangle, and the two side lengths are the same. If I'm determining the hypotenuse based on this, then my r squared would equal my x squared plus my y squared, or r squared is going to equal 1 squared plus 1 squared is just 2. So r would be the same as the square root of 2. Based on that, I can state that sine of 45 is the same as my opposite, 1 over the hypotenuse, the square root of 2. And when I rationalize it, that's going to give me root 2 over 2. Now my cosine would also have an adjacent, which is still 1, over the hypotenuse, square root of 2. So it's still going to be root 2 over 2. Tan of 45 we should know, because it's what we usually use to check and see if our calculator is actually in degree mode. It's just 1 over 1, and tan 45 is just 1. Now, in order to solve for if my angle is 60 degrees instead of 45 degrees, then we create an equilateral triangle where all three parts are 60 degrees. In this case, we do it where all the side lengths are 2, which means that when I split it in half to make a right angle triangle, then I'm going to say that the x value of this right angle triangle would be half of that length, or just 1. And then I have an altitude, a height, or my y value, which I can solve using my Pythagorean theorem. I'm going to say that my height squared would equal my hypotenuse squared minus my adjacent side squared. So my height squared is going to equal 4 minus 1, or 3. My height is just going to be the square root of 3. So now I have a r value of 2. I have an x value of 1. And I have a y value of root 3. And I can state what my ratios are. Sine of 60 is going to be my opposite, root 3, over my hypotenuse of 2. Cos of 60 is my adjacent of 1 over my hypotenuse of 2. And tan of 60 is going to be my opposite of root 3 over my adjacent of 1, which I can just simplify to the square root of 3. If I take the same equilateral triangle and I rotate it on its side, then I'm going to have 60 degrees here, here, and here. And now I'm just splitting it in half along the x-axis to create a hypotenuse that's still 2, an opposite that is 1, and now my adjacent is going to be the square root of 3, because it's the same right angle triangle that we had before. We're just solving it based on the other angle. When I do this process, now my sine is going to have an opposite of 1 and a hypotenuse of 2. My cos is going to have an adjacent of root 3 and a hypotenuse of 2. And my tan is going to have an opposite of 1, an adjacent of root 3. And when I rationalize this, this is going to be root 3 over 3. When I put it all together, I have my special triangles. I have my angle of 30 degrees, angle of 45 degrees, angle of 60 degrees with the exact ratios, or the exact side lengths, I should say, of 2, 1, root 3, which is the same when I do it with 60, or 1, 1, and the square root of 2. Now I can simplify this and state, well, what would happen if I made the hypotenuse 1 in all of these cases? Then all I'm doing is I'm dividing from the 30-degree one all of these side lengths by 2. So it's going to give me 2, 1 over 2, and root 3 over 2. If I want to make the side length, or the hypotenuse, 1 from the second triangle, then I would divide all of them by the square root of 2. And that's where I get these exact measurements. Last but not least, if the hypotenuse is 2 again, I'm just going to divide them all by 2 and get these 3 side lengths. The triangles above are similar to the ones in our investigation. In each diagram, the horizontal distance is x, the vertical distance is y, and the hypotenuse is going to have an r equals 1. And this is the really important part. My r value equaling 1. If I do that and have an r value where it equals 1, then if I take sine of 30, it's going to be 1 over 2. If I take sine of 45, it's root 2 over 2. And if I take sine of 60, it's root 3 over 2. Interestingly enough, if my hypotenuse is 1, that's equivalent to the y value in every single one of these ratios. My cos from the previous page, we know, is going to be cos of 30 is root 3 over 2, cos of 45 is root 2 over 2, and cos of 60 is 1 over 2. Once again, when my hypotenuse is 1, that perfectly matches up with my x values in every single case. The ones that are a little more complicated are my tan values. Tan of 30 degrees is root 3 over 3. Tan of 45 is 1. And tan of 60 is just the root 3. Those ones are not obviously evident in these special triangles. So that takes care of 3 of my special angles. The other 2 special angles are going to be 0 degrees and 90 degrees. Now what happens with these cases? Well, consider a rotational angle of 0 degrees, where my x is 1, my y is 0, and my r is 1. If I haven't rotated it all, then if I did this on my grid at 0 degrees, which would be right here, my initial arm is going to match up perfectly with my terminal arm, and they have to be the same length. That's why I get x of 1 and y of 1. When that happens, I haven't rotated up at all, which means that my y value has to be 0. When I do that, I'm going to say that if sine is y over r, then that's going to give me 0 over 1. Sine of 0 is just 0. My cos value is going to be x over r, or 1 over 1, and my cos is exactly 1. My tan value is going to be y over x, or 0 over 1. Tan of 0 degrees is also 0. And you can plug all these into your calculator to verify this. At 90 degrees, it's going to be looking like this. Where I have my initial arm is here. My terminal arm is going to be here. And I can see that based on my terminal arm, I have my y value is going to be the same as my r value. Because remember that I create those right angle triangles going to the nearest x-intercept, or nearest x-axis, and the x-axis exists right in the middle here, at the origin. So I have y and r both 1, and when it exists on that y-axis, my x value has to be 0. What does that mean for my ratios? Well, if sine is y over r, that's going to be 1 over 1, or just 1. If cos is x over r, or 0 over 1, that's just going to be 0. And you can see that they're the exact opposites when it's 0 and 90. If sine is 0, cos is 1. If sine is 1, cos is 0. And last but not least, if tan is y over x, then that's going to be 1 over 0, which is undefined. Why is it undefined? Because it's a division by 0. Remembering that we can't divide by 0 in math, so we call it undefined.